of 1 over x squared. So in this case, I don't have any numbers out in front of my logarithms to worry about moving them up to an exponent. So I'm going to go straight for the addition. And so addition implies what with logarithms? Multiplication. So I'm going to rewrite this as log base 2 of 1 over x times 1 over x squared. Oh, and I should also mention that these properties only work, the condensing properties only work if you have the same base on the logarithm, by the way. I can't condense a log base 2 with a log base 3. They have to be the same base to be able to use these properties.
Would that be like no solution?
It would just be already in simplified form, so that would be as far as you could go. If this had said log base 2 plus log base 3, then there wouldn't be anything we could do with it in that case. Now, there is something we can do with this, though. I can actually go ahead and multiply my 1 over x times 1 over x squared together and make it log base 2 of 1 over x cubed. So this is a perfectly acceptable answer for this particular problem. I will say on a multiple choice test there are varying ways that you might see this answer written. Not so much number 6, but definitely number 7. I've seen this written in a couple of different ways. So I'm going to show you a couple of different ways to write it, just in case it pops up on a multiple choice question. Another way to write 1 over x cubed is x to the negative 3 power. Sometimes they'll write it like this. And then other times they'll even bring that negative 3 out in front and write it as negative 3 log base 2 of x. Now, on homework, you don't have to write it every single way that it could possibly be written. But I'm just showing you this in your notes so that if it does pop up on a multiple choice test and you get log base 2 of 1 over x cubed for your answer, but the choice is negative 3 log base 2 of x, that you're able to make that connection between those two answers. You definitely wouldn't have to choose between these two. It would be one or the other. They're equally correct, by the way. But just making sure that you're able to recognize that on a multiple choice test, no matter what form they give it to you. All right, let's try another one. This time we're going to do log of x squared plus 3x plus 2 minus 2 log of x plus 1. By the way, what's the base on this logarithm? Good, thank you. But log base 10. If it doesn't have a base, it's the common log, which is log base 10. Any ideas on what I should do first here? I heard somebody whisper. Yes, move the 2 up to the exponent. This 2 becomes an exponent on the x plus 1 only because it's the only thing getting multiplied by the 2. So I'm going to write it as log of x squared plus 3x plus 2 minus log of x plus 1 squared. Then I'm going to change subtraction to division, and when I go from subtraction to division, I condense 2 logs down into 1, and it's going to be log of x squared plus 3x plus 2 on top, and x plus 1 squared on the bottom. And I'm actually not finished, because this expression can be simplified. Any ideas on how? Just, you got it, factoring, that's right. So if I factor my numerator, isn't that just x plus 2 times x plus 1? Because 2 things that multiply to give me 2 that add to give me 3 are 2 and 1. And hopefully you can see why I would do that, because I can actually cancel out my x plus 1s. And for my final answer, I would write it as log of x plus 2 over x plus 1. Now I'm finished. So if your expression inside the parentheses can be simplified, we want you to do that, whether it be by factoring, multiplying, or whatever operation that you see fit. Okay.
Since you, like, if you were starting with that one that we just found and you're going to expand it, would you have to distribute your negative
No. The question here is, if we started with our answer, we expanded this, would we need to distribute our negative?
Oh,
The answer would be no, because that x plus 1 is all one thing that would be inside the parentheses.
that's a great question. Did you guys hear that? Could you hear it? Okay. Anybody not able to hear that question? Because that's a really good question. All right, I think I have time for just one more thing I want to show you. I'm going to do one more small example of condensing. So let's do ln of x plus 2 ln of y minus ln of z. I just wanted to, I thought about giving you one example where we have more than 2 logarithms to condense. And so the first thing that you would do on this one is to move the 2 up, of course, on the ln of y. And then if you have more than 2 logarithms, what you want to do is work from left to right. Okay, so you want to condense these 2 first, so that you have ln of x times y squared, because addition implies multiplication. And then you can condense these 2. So you want to do it 2 at a time, from left to right. So it'd be ln of xy squared divided by z. And that would be your final answer. So if you have more than 2 logarithms, just take your time, work from left to right, 2 at a time. So let me go ahead and give you your assignment for this section. And then remember, your quiz on Friday is over Monday's assignment, 4.4 only. But you'll certainly have time to work on both 4.4 and 4.5 tomorrow. Over here to the side, page 332 is your assignment. I want you guys to do the following numbers for me. 13, 15, and 17. Then 37 through 43 odd. Then 57 through 61 odd. And then 71 through 77 odd.